So picking up where we left off, we're going to keep moving through with our bonding. Okay. So now that we looked at ionic bonds, now we're going to look at covalent bonds. And this is how our electrons are shared to create bonds. So in ionic bonds, they're moving. There's a give and a take. In covalent bonds, there's a sharing. And you can see this in the picture. Okay, you see how there's electrons being shared in the middle here. So we're going to look at that. So first, we need to determine how many bonds. The valence electrons are shared to reach the magic number 8. Remember that number 8 is super important at any time we're talking about bonding. And again, I give you those exceptions. Helium and hydrogen only need 2 because that inner ring, that first ring, will only hold 2 electrons. And then boron is just really weird, and so it just needs 6. So don't really worry about that one too much. You won't see it super often, but it's there. Just know it needs 6. So to determine the number of bonds, we have to determine the valence electrons in each and subtract from 8. Again, seeing those exceptions above. So group 4, you need 4 electrons to get to 8. Group 5 needs 3. Group 6 needs 2. Group 7 needs 1. Okay. Remember, we're only looking at nonmetals because nonmetals are going to do those covalents, and nonmetals are in those groups, really groups 4 through 8. But again, that last column, the 8th column, is our noble gases. They're not going to react with anybody. So we really do not need to worry about trying to make those work. We're looking really at columns 14 through 17 in this bonding situation. So there's different types of bonds. Most likely you'll see is a single bond. It's when 2 electrons are shared between 2 atoms. They're represented by 2 dots or a single line. So here's my example. So 2 chlorines are going to be attached, and you can kind of see here, these 2 dots are being shared, and these 2 dots can be represented by this line instead. It's the same thing, so don't be like, oh, why does it look like this? They're both the same thing. The line just might make it look neater, especially if you're doing a lot of different elements. Okay, a double bond is when 4 electrons are shared between 2 atoms, and they're represented by 4 dots or 2 lines. Okay. So here we have 2 oxygen. Oxygen both need 2 electrons to get there. So really they need, they're going to share their 2. This one's going to come over here. This one's going to come over here. You see you have your 4 dots. And then here, just the lines represent each of the 2 dots. So 2 dots in the middle, or 4 dots in the middle with 2 lines, and then each of these lines on the outside represents another 2 dots. So really think about each line represents two dots. Okay, a triple bond is when 6 electrons are shared between 2 atoms, again represented by 6 dots or 3 lines. Okay, most notably you'll see this with nitrogen. It's the most obvious one with triple bonds. And so nitrogen, it needs 3 here, it needs 3 here, so they're going to share their 3 that they have that are open, and we have our 3 dots, or you would have your 3 lines in the middle. Now, technically, you could have a quadruple bond between 2 carbons. It doesn't happen often. That really is happening in just carbon-based things, like a diamond or charcoal or something like that. However, most likely carbon is going to be attached to another thing and then might make a single, double, or triple bond with another carbon or with another specific atom before it will go quadruple. Usually if it's quadrupling, it's between carbon only, and it's very, very rare that it does that. Speaking of covalent, we have to talk about some atoms that cannot be left alone. So if you have a younger sibling, or if you ever babysat for cousins or things like that, I want you to think about a 3 or 4-year-old. Okay, now there's always a joke what happens when the kids get silent, and that is something terrible is about to happen. And that's because normally you cannot leave 3 and 4-year-olds alone by themselves, even for 5 minutes, because they'll probably get into the flour or the diaper paste or playing in the toilet or whatever. They're very mischievous because they're trying to learn. And so we want to talk about elements that are kind of like 3s and 4-year-olds. They cannot be left alone. under any circumstance. They're super unstable. They're going to cause so much trouble. So they cannot be left alone. So there's 7 of them to remember. The best way to remember them is the fact that you make the number 17 with them. And I'm going to talk about how that works. So the 7 are hydrogen, that's H2, nitrogen, N, oxygen, O, fluorine, F, chlorine, Cl, bromine, Br, and iodine, which is I. And the way to think about it is hydrogen is in the number 1 column. So there's the 1 for that 17. And then if you look at the periodic table, NOF is in that first, or the second row, I should say, that first row in the P block. And it's, so it makes that top part of the 7. And then if you notice, under fluorine is chlorine, bromine, and iodine. So if you looked across N to F, and then F down to I, makes the number 7, 17. So these are called diatomics. And they will either pair up with themselves, so N will pair up with another N, or they will pair up with another element. So chlorine might attach to iodine or things like that, or hydrogen will attach to fluorine. Most likely it'll attach to hydrogen, but they'll kind of attach to each other so that they cannot be left alone. So finally, metallic bonds. These are the valence electrons, and these s&p orbitals of the metals are going to leave their respective atoms. So all these atoms are going to kind of come together in like a hodgepodge, like a giant soup. And the electrons from the s&p orbitals are going to kind of break away, and they're going to make a sea of electrons. Okay, and then they're going to move freely through. And because these electrons have left, quote unquote, left their atoms are now more positively charged. Remember, if you lose electrons, you become positively charged, and they are going to be attracted to these different positive charges, even if it's just temporary. Okay, so you can kind of see here. So here's my metal ions. Those are the blue with the positive, and then my little red dots are my electrons that are kind of moving around. So some are attached, and then some are free as they kind of move around. Okay, and then they make things like this. They're going to make what's called a network solid, okay, or a crystal lattice, depending on what's your structure. But they're going to kind of move around. So you have some cubic, so you have iron and chromium. Here we have aluminum and silver and gold and copper. And over here we have zinc and magnesium and titanium. So when they attach, when 2 metals are going to attach to each other, or within themselves, that you're going to get this structure. Okay. So that's the end of bonds. So what you're going to do now is you're going to work on the next activity, and then from there you're going to do your boom cards as a way of checking your knowledge.